Hi guys, in this lecture we're going to start a conversation about direct variation. We're going to be working on identifying proportional relationships, or identifying direct variations. So we'll start off by giving a list of things we want to look for when we're identifying proportional relationships. 1. We want the graph to be a straight line. It needs to be a linear graph. 2. The graph needs to go through the origin. The origin is point 0, 0. It's right where the x and y intercept meet. It needs to go through the origin. And the last thing, the graph is not vertical or horizontal. This means that the slope is not equal to 0 or it's not undefined. So taking a look at this first example here, we have our graph. It is a straight line. So that's the first thing we're looking for. Second thing is, does it go through the origin? The origin is where our x and y intercept meet, so right here there is a point right on the origin, so our graph does go through the origin. So it has the first two, and then we need to check the slope of the line. It's not horizontal, so it doesn't have a slope of 0, and it's not vertical, so it doesn't have an undefined slope. So yes, we have a line going through the origin that is a straight line. So it is a proportional relationship, or a direct variation. Looking at our second example here, it is a straight line. We do have a straight line here, but it's not going through the origin. It doesn't go through the point right in the middle here. So that means that it is not a proportional relationship. It's not a direct variation, because for it to be a direct variation, it needs to be a straight line that goes through the origin. So this one is not a direct variation. The last situation you might come about is if you're given a table. There's two ways you can go about finding if this table is a direct variation or not. The first way would be to graph all the points. So if I had a coordinate plane, alright, so I brought up our coordinate plane over here. So plotting these points, 0, 0 is right at the origin. 1, 3, or our x is 1 and our y is 3, means we go over 1 on our x and up 3 on our y. 2, 6 is over 2, up 6. Then 3, 9 over 3, up 9. So plotting those points and then drawing the line between them. We see that we have a straight line, and it does go through the origin. It goes through 0, 0, which we have right here. So we have a straight line through the origin. The slope is not 0 and it's not undefined. So this is a proportionate relationship. So one way to find it would be to graph it. The other way to find it would be to look at the slope between each point. So from 0 to 1, the change is 1. So the change in x is 1. 1 to 2, the change in x is 1. 2 to 3, the change in x is 1. 3 to 4, the change in x is 1. But we also need to look at our change in y. 0 to 3 is 3. 3 to 6 is 3. 6 to 9 is 3. And 9 to 12 is 3. So as you look at these, we have a change in y, which is 3 for each of them, and a change in x, which is 1. So our slope would be equal to 3, and it's consistent throughout the entire table. 3 over 1, 3 over 1, 3 over 1, and 3 over 1. So we have a consistent slope of 3 throughout the entire table. And also in this table, it shows us right here that we have a point of 0, 0. So it does go through the origin. It tells us that right in the table. So we know that we have a slope of 3, meaning it is a straight line, and it goes through the origin. So you can tell just from the table that it is a proportionate relationship. So two ways you can go about finding if it's proportionate by using a table. That's all I have for this lecture. Now if you could go on to IXL and complete section R1 with a SMART score of 80 or better. If you have any questions, feel free to ask. Have a great day.